Okay, today is the last bit of the exponentials and logs, and this is growth and decay. So things like growth would be increasing numbers of bacteria or populations, something like that. Decay would be things like radioactive decay, that sort of thing. So these can model it. So if you've got some quantity, and we'll call it A here, then we can say that at any time it depended on what you started with, which is the A0, and then how long since the start, and then there's some constant in there. And it turns out that many things that E, the natural number, so that's how it got its name, the natural number, that E to the power of KT is a thing that models it very well. All right, so E as opposed to any other number. So for at the bottom of that little bit there says that K is the constant, and so if something's growing or getting more of, then it'll be positive, but for decay you're getting less of, it's a negative. Now, if you forget that, or the little note says, if you forget that, it doesn't really matter, because the mathematics will take care of whether it's a positive or a negative. And so let's move on to a question. Okay, here's our first question. It says, after 10,000 years, a sample of radium 226 has decayed to 64.7% of its original mass. Find the half-life of radium 226. So what are the important things that we know? So first of all, one of the important things is the 64.7%. And it says of its original. Now, we don't know what the original is, but it doesn't matter, because we can write it down in terms of that. So, and that's what's been done here. So A is 64.7% of A0. So what does that mean? Well, let's put 64.7% in a decimal, and there it is next to it, 0.647 A0. The time, well, you were told up here after 1,000 years. So the time is 1,000, and we're wanting to find out what the constant is, first of all, and then we can work out what the half-life of radium is. All right, so constant is the thing we need to know. So if we've got that A equals A0 E to the, and because it's decay, I'm putting negative KT. Now again, if you just put K, that's fine, and the mathematics will work out. So let's put in some stuff. So 0.647 A0 equals A0 E to the negative K times 1,000. Oops, extra zero there. Of course, the A0s will cancel. So as I said, we don't need to worry about them. So we get 0.647 equals E to the negative 1,000 K. Now, if we want to do something about this side over here, we need to find the K, so we need to get rid of that. So log to the base E, natural log, ln both sides. So when we take ln both sides, we get ln of 0.647 equals negative 1,000 K. So K then would be negative log to the base N of 0.647 over 1,000. Alright, so what we end up then is that A equals A0 E to the when we go back here, I put, where are we? Just want to choose a colour here. There we go. I put a negative here, and so we found that K also has a negative in it. So because I've put a negative there, there's that negative there, and that negative there, make a positive, alright? So it's positive ln 0.647 over 1,000 t. Alright, so now we've got that. The next thing is we need to, what does half-life mean? Ooh, that's a bit awful. Alright, those who do physics, hopefully we've already remembered that half-life means the time for half of it to go. So half-life means when your amount is a half of your original. So again, we put in that information. So half of my original equals my original e to the ln 0.647 over 1,000 t. Those of course cancel. And do another step as well. Take log to the base n of both sides, base e of both sides. Alright, and then you can rearrange, of course, but with something like this. Probably going to be easy to do, so you will use your calculator, you can use the solve function or whatever else, and so the time actually comes out to 1591.945 years, so saying approximately 1,592 years. Alright, so there's a decay thing. Some people might be worried about that the final thing, that decay hasn't got a negative. Don't forget this bit here when we're taking the log, that you get, that's actually a negative value. Alright, so just kind of have faith in the mathematics sorting itself out. If you're worried about whether back in this step here, alright, back in this step, to write it as a negative or a positive with K, just write it as e to the kt and work with that every time. And the mathematics will take care of whether it's a positive or a negative. Alright, let's have a look at another example here. Population of a town was 8,000 at the beginning of 2007 and 150,000 at the end of 2014. Should growth is exponential, find the population at the end of 2016. And then part B, in what year did the population reach 30,000? Alright, so I'm using P, population. P equals P0 e to the kt. And you already noticed that I've got some underlined stuff. So, because we want to know like our time, when is our time start and finish and all the rest of it. So, you know, there's a significance when we're talking about the beginning of 2007. Because that means that all of 2007 gets counted in. And then the same one there, it says at the end of 2014, so that means all of 2014 gets counted. So that talks about population. Population, P, which which is 15,000 at the end of 2014, and of course P0 was 8,000 at the start of 2007. So it's not just simply 14 minus 7 equals 7, it's actually, because 2007 is encountered, it's actually 14 minus 6. Why minus 6? Because here we're talking end, here we're talking at the start. So if we want to look at this bit, the start of 2007 is the same as the end of 2006. Okay, so now we've got two references that are common that we can work from. So 2014 minus 2006. So that means our time is 8 years. All right, that's important that you carefully read and get that kind of stuff. Because under the pressure of the exams, that's the kind of stuff that's pretty easy to overlook or miss out on, with all the stress involved. All right. So what does that mean? That means that we've got a population equation, 8,000, because that's what it started at, e to the kt. Putting in the information, we know that the population is 15,000 after 8 years. Right, there's all of that. Divide both sides by 8,000, do some cancelling, and you get 15 on 8 equals e to the 8k. Log to the base e of both sides. So k is in exact values. 1 on 8, log to the base n, 15 on 8. Alright, so that helps us in that now we know that P equals 8,000 e to the 1/8 log to the base e, so 15 on 8, 15 on 8 t. Alright, let's be messing that end a bit, but you get the idea. Alright, so now we can work with that. Best to leave that as exact value and not find a decimal, and put it back later on if you need to. Alright, so part A is reasonably straightforward. It says at the end of 2016, so that's another 2 years later than the end of 2014, so that will be time equals 10, and then we whack all that information in. P equals log to base e ln. I'm mixing up all my different things there. Alright, and then you do that and put that in your calculator and you get 17552.6. Can't have 0.6 of a person. You've either got a whole person or not. So in this case, got to be a little bit careful here. We actually, when we do the rounding, we don't round up, we round down, even though it's over 0.5 or over. We round down. It's from what I just said before. You can't have a fraction of a person, you can only have a whole person. So the way you need to interpret it is, if you haven't got a whole person, you haven't got one at all. So 17552 is our population. Alright, part B for the example asks us when P is 30,000. Alright, so 30,000 equals 8,000, and then e to the 1/8 log to the base e of 15 on 8t. Alright, so I'll do a couple of steps here. Divide by 8,000, do some cancelling of some zeros and other stuff, because 2 goes into 30 and into 8, and then to take the log to the base e of both sides at the same time. Right, so when I do that, I'll get log to the base e of 15 on 4 equals 1/8 log to the base e of 15 on 8t. So t will be equal to log to the base e of 15 on 4 over 1/8 log to the base e of 15 on 8, which is fine for me to do, but a question like this is more than likely going to be in exam 2 when you've got your calculator. So in which case I'd be looking at this bit here and just doing solve. And always rearranging stuff is fine, but all it does is it takes time. So when I do that, you actually get 16.82 years. Alright, so it's not a whole year, so 16 years from the beginning of 2007 brings you to 2023, and it's so 2007 plus 16 is 2023. So, but we've got 16.8 years, so the final answer is during 2023. Alright. Alright, so that's about it. There's one more thing, one little note. Alright, and that little note is about K. Just in reading the questions, when you read, if it increases by a certain amount, so by a rate of R, then K is the original plus the extra. So that comes as 1 point, whatever that R is. And conversely, if it's, so there's the example, increase by 15%. So it's 15% as a fraction, as a decimal, I should say, is 0.15, so 15.1. And so conversely, if it's a decrease, rather than adding that 0.15, then as we say here, we take it away. So it's 0.85 of what it was. All right, so it's decreased by 15%, decreased from 100% down to 85%, and so that's your 0.85. All right, so those two words, they're helpful to you, and of course, as I did in that first example there, when it did talk about that 64.7% of its original, and so then you go, your amount is then, say for the decreased one, so as I'm writing in green, it's 0.85 of our original amount. Alright, so as you can see, these sorts of questions with the words here, lots of places to get trapped on that, so you need to be allowing yourself, or forcing yourself, just to give yourself that little bit of extra time to read and make sure you understand it. Alright, have fun with that.